that means you need this one. Apart from that, then to control this, you have a controller. That's what I called yesterday. You have a mechanical system or a mechanical structure. This is robot made of links and joints, and there are motors attached to each joint. Right? There are joints M1, M2, M3, and apart from that, there is a wrist mechanism. There are 3 motors, M4, M5, and M6, and there are 3 joints internally with a small this one, which provides the possibility of orienting the end tool with respect to rotate the tool with respect to x-axis, with respect to y-axis, with respect to z-axis. You can rotate. So that's why I said 3 degree of freedom is provided by wrist mechanism. The 3 joint provides overall system 3 degree freedom. We have 6 degree freedom. So this needs to be controlled. You have the robot controller. The robot controller is made of a computer, and it also has other electronic circuit, which is called the signal amplifiers and power amplifiers, power amplifiers. Power amplifiers are used for amplifying the signal coming from the robot actuator. I told you that robot control is a digital computer. Generally generates signal in the range 0 to 5 volts and few milliamps current. That signal cannot directly drive the motor, which is driving the robot. Correct? The motor may need 100 volt, 200 volt, even 500 to 1000 also, bigger robots. So then they need high current also. 5 amp, 10 amp, 50 amp, depending on power rating. So that power cannot be generated by the controller, the robot controller. So the signal coming and control signal coming from the controller, robot controller, will be amplified by these power amplifiers. Correct? So that by the power amplifiers, finally given to the actuator. In this case, motors. Motors are driven by power amplifiers. Again, apart from the actuators and the mechanical structure and controller, embedded controller, one of the most important things, what we call the feedback sensors. The feedback sensor measure how many these joint has rotated. Correct? As I told you, you have a motor. Motor is attached to the joint. Joint is connected to the link. Correct? There are 2 links. There are 2 links connected to the joint. I call this one link L0. This is my L1 link. So if I rotate this motor, the joint will rotate, which in turn make the L1 to rotate with respect to L0, relative motion. That's what is going to happen. Now this is given by signal coming from power amplifier. They call it power amplifier. Power amplifier receives control signal from the ECU, electronic control embedded control unit. Here the ECU generates 0 to 5 volts or 0 to 10 volts. That is not sufficient to drive the motor. For example, this motor is 100 volts and 10 amps current is taking. So 1 kilowatt motor. Correct? Power equal to voltage into current. So it is 1 kilowatt, that means 1000 watt power to drive this link. Correct? Because the load carrying capacity required. In that case, the signal coming by ECU is not sufficient, 0 to 5 volts or 10 volts, and it can give only milliamps current. So that signal is given to power amplifier. Power amplifier in turn amplifies to required voltage level. What is the voltage level? That depends on motor voltage. If I have a motor which is 500 volts, the amplifier, power amplifier should generate 0 to 500 volts. And also the current requirement based on power rating. Correct? 0 to 10, 0 to 100. That is our kilowatt rating of the motor. Apart from this, now the joint is rotating. How do you know the joint has rotated? Correct? How do we know that joint has rotated? For that, what I said again, make it clear. I have my controller or ECU. ECU generate control signal. This goes to power amplifier. Power amplifier in turn is connected to the motor. Motor is connected to my joint, rotary joint. I have the single degree freedom robot. So this is my L1. This is L0, which is grounded. So when this motor rotates, this is joint J1, which is rotary joint. The joint will rotate. Because of that, the L1 joint also will rotate with respect to L0. So end effector also rotate. So end effector is going to move like this within this one. Right? It can take any different position. So this is called 1 degree freedom robot, which can in the end effector can pick and place object anywhere in this circumference of the workspace. This is called workspace. Okay. Now I gave a command to motor rotate 0 to currently at 0 degree. Rotate 30 degree I am giving command. So, which is ECU is giving. So the power amplifier generate control is given to the motor. Motor rotates. How do you know motor actually rotated? Correct? If I give the, for example, this is a servo motor. I told you previous class, if it is a servo motor, it takes, for example, 0 to 10 volts. For example, the controller generates 0 to 10 volts. That is amplified to 0 to 100 volts by power amplifier. It is given to servo motor, this motor. If I give 0 volt, motor won't rotate. If I give 10 volts, the motor will rotate 10 degrees. Correct? I am talking servo motor, not a DC motor. In the servo motor, by giving voltage, you can control the angle. Correct? Any angle can go and precisely stop. Okay. Now, I gave 10 volts. The servo motor rotates 10 degree. But the joint may have, correct, friction. Due to that, the motor may not really rotate. If I give 10 volts to servo motor, it should rotate 10 degree. Servo motor tries to rotate because of friction in the bearing and any other external forces. The motor has not rotated that 10 degree. Instead of that, it may enter 9.5 degree only. How the ECU knows? If I want to precisely want to control means, I will put one sensor attached to same shaft. I will give it in different color. In the same shaft, the motor is at a joint. In the same shaft, I can put a encoder that is called rotary encoder. It measures angle. Sometimes many motors, they have built-in rotary. Inside the motor itself, encoder will be there. You can buy a motor, servo motor, this one, which has built-in encoder. You need not buy separately. So that means if we give a command 10 volts, the motor rotated this one. If it doesn't, you can read this encoder value. That value can be given to ECU. It is called a feedback sensor. Feedback sensor. Already we talked about this. Later also we are going to talk about this when we talk about control system, open loop control close. So if you give this one, EC knows that suppose instead of 10 degree, it moved only 9.5 degree. The EC knows that there's an error of 0.5 degree. What it will do is, it will instead of giving 10 volts, it may give 10.5 volts. It may give 10.5 or 10.2 volts additional voltage. So the motor will further rotate, overcome the friction. It will go to 10 degree. Once it reaches 10 degree, because please note that EC is continuously giving voltage, also continuously monitoring the feedback signal. How many degrees has rotated? That is the job of the encoder. So once the joint or motor reaches the 10 degree, the encoder EC knows that it need not give further voltage, stop the voltage. So the position is measured. This is called a closed loop control. So that means you will have encoder at here. You have a motor one end, other end you have encoder. I say E1, M1. This is my J1. Correct? So in your robot, you have a joint. One side of joint may have a motor which is going to drive. Joint cannot move it. Other side of the same shaft, you may have an encoder, or inside the motor itself, you can have an encoder. Anyhow, in mechatronic system, as we told that, you have a mechanical structure controlled by an actuator. And apart from that, you have a feedback sensor to measure the parameter. What it, in this case, joint angle. It may be linear displacement, or it can be force, flow rate. That you are trying to control a parameter mechanical system. That parameter will be measured and given as a feedback signal to the ECU, so that ECU can overcome what you call as disturbances. The friction is called as disturbance, no doubt. Correct? Whichever stops. For example, your whole idea is the motor has to, the joint has to move 10 degree. That is driven by motor. If there's a friction in joint or external force is stopping this one, that is called as disturbances. The controller should generate sufficient control signal and give it to the power amplifier, and that should be amplified, given to the motor, so that overcome the friction, all the external disturbances. Still the joint or the end effector should reach that degree, particular degree. So that is called a disturbance rejection. The primary goal of disturbance rejection is the primary goal of feedback control or closed loop control. Feedback or closed loop control. Most of the machine, wherever you want to control very precisely, accurately, then you will use feedback controller. In that case, what you need is additionally, you need a sensor. Correct? Additionally, you need a sensor and additional electronic circuit to detect the error. All the six, you have to write program. So the feedback control become expensive. Instead of that, when I talk about the control system, we'll talk about what you call the open loop control. In open loop control, you don't need the feedback sensor. And the controller also not complicated, very simple. correct? Cost effective. Only problem is if I give the voltage, we know that if I apply 0 to 100 volts, the motor has to rotate 0 to 100 degree. I gave 50 volts and I expect 50 degree the motors to rotate, so joint also rotates. If it doesn't happen, there's no way of knowing. Correct? In that case, the end effector may not reach the desired position. Correct? I want to do 90 degree from this location, so I give 90 volts. It may come only. It is like this. This is my joint motor, and I give the voltage. It has to come vertically 90 degree. So I gave the motor 90 volts by power amplifier. It comes only 18 degree or 85 degree. Correct? Open loop control, you won't know because there's no feedback. There's no feedback sensor. One advantage is your open loop control is cost effective. Disadvantage is if there are due to external disturbance of friction, all those things, the end effector doesn't reach actually 90 degree from the current location. It reaches only 85 degree, 87. You don't know. That means the end effector robot cannot do the accurately. Task cannot. It has to pick an object, move 90 degree and place it. It miss the object. This is drawback of open loop control. So you need to provide closed loop control. So typical industrial robot has this. Already we saw about this. Now, what we are going to talk about is what you call as modeling the mechanical system. Modeling mechanical system. That is what today we are going to see. 1 or 2 classes. First thing is what is in CAD you call mathematical modeling. For example, we take a simple mechanical system which is called spring mass damper system. Spring mass damper system. Okay, this system has 3 mechanical system means it as I told you, any mechanical system can be, if you disassemble any mechanical system, your engine or your robot, correct, finally end up the individual components. Those components are building blocks of mechanical systems, correct? Building blocks are bricks. Building blocks are bricks. Bricks of mechanical system is individual components. Individual components. Okay. In this case, I have a system called spring mass damper system. It has a mass. Mass is m kgs, and it has a spring. Its stiffness is K, and there's a damper. The technical name is damper. Sometimes colloquially in US they call it dashpot. Correct? The correct name is damper. Correct? You know, in shock absorber you have a damper and a spring. That's what it is. So this is what we are trying to represent. Spring mass damper system are nothing but this together. Together, these two forms what you call a shock absorber. All automobile has shock absorber, which connects wheel with the body of the vehicle. Correct? So the body of the vehicle, which is also called as sprung mass. This mass is called as in case of automobile, it is called as sprung mass. What is that? I told you yesterday. That's what I was drawing. For example, you have a car, something like this. This is a side view. Inside that you have seats, front seat, back seat. There are passengers sitting here. Correct? And you have engine, you have a gearbox, you have a transmission system, correct? Then you have differential, which in turn, okay, this is the body, correct? Then you have trunk in which you have luggage, okay? All these things are there, okay? Now, this is called as body. Inside body, you have seats, floor, all those things, engine, all those things are connected and bolted on a frame. That there's a frame is there on which engine, we call chassis. You call it a chassis, correct? Chassis is a long beam-like structure, like something you generally will look in a bus or this, and definitely you know that, I need not tell. So something like this, yeah, structure, mechanical structure, we have beam to this one, on which only you are going to place your engine. Correct? Your engine will be mounted on the front. This is the front side. Correct? Then you have the gearbox, but then you have the transmission system, then you have differential, correct? Then you have steering system, then it is connected to wheels, back wheels, correct? But you are not connecting directly. This is your front wheels somewhere here on which you have the body. I'm saying top, from the top you are seeing. Now, this is what your beam or chassis, on which please note that the whole thing, engine, everything is mounted on the chassis, gearbox, the passenger seats, on which passenger sitting, you have the luggage of this one. All those things are inside this vehicle, and now you have wheels, right? And the whole, this is connected to a shock absorber, spring and damper, correct? Connected, that is connected to wheel. You have a spring and a damper, and this is connected. Wheel is connected not directly to the body, which is, this is called as sprung mass. Because why it is called springing, moving up and down, correct? So the whole body is called as sprung mass, and there is a shock absorber. Shock absorber connect the sprung mass, nothing but body of the vehicle, including passenger engine, all those things, which other end of the shock absorber is connected to wheel. Wheel is moving over the road, right? So that means when wheel is moving on the road, there is a force, what you call normal force, which is acting downwards. I call as normal force acting downwards because of the sprung mass. Sprung mass, if I say my car has a weight of say 1000 kg total weight, out of that maybe 800 to 850 kg will be sprung mass. That will be sprung mass. And the remaining part goes to wheel and the shock absorber, all these things. Right? Sprung mass is supported by the shock absorber. Shock absorber other end is connected to the wheel. Okay. Now, the whole thing is, now I say that for understanding part, we'll take that sprung mass 800 kg. Correct? So 800 kg is the sprung mass, which include passengers, luggage, engine, all those things. That is supported by 4 wheels. And each wheel is going to support 200 kg, correct? 200 kg mass will be supported by individual, because I'm saying 4 wheels are there, I'm saying side view. So now this multiplied by 9.81 is the gravitational acceleration. Mass multiplied with this one is going by the force, normal force, which is acting downwards on each wheel. And that force is acting on the tire. Tire is touching the road surface. So earth provides equal and opposite force, which is called a ground reaction force. That is called a Fg. The force acting downwards due to the mass of the vehicle is called Fn. Equal amount of the force is generated by the road, which is called as Fg. Right? This force. So because of the tire is remaining. So on each wheel, this much force, 200 into 9.81 Newton force is acting. That is called, correct? So the normal force equivalent is this one. Now we know that the tire is touching the road surface. The body from the tire, you have this one shock of the one end, other end is connected. So because of that, your vehicle is under some height. This you call a ground clearance, correct? You call a ground clearance. Correct? So for example, in a car, say for example, 50 centimeter, 90 centimeter, some, correct, depending upon type of vehicle. SUVs have 2 feet also. Higher the ground clearance, your vehicle can go uneven road also, village road, all those things, where the road is not a flat, it is this one, undulation is there, correct? So village road or countryside, all those things you can travel. That's why SUV ground clearance will be higher. But ground clear higher means what is the drawback? COG, center of gravity of the vehicle, will be higher. If it is the sun, when you take a turn, vehicle can roll, correct? It can topple. So higher COG is not good. Lower the ground clearance, so the distance between road surface and the COG point of vehicle, it is better for taking turns. That's why race cars, the ground clearance will be less than a feet. Those cars cannot be driven in regular roads. It will, the bottom of the gearbox, all this thing will touch the road surface. Even small bumps it will hit. So they're meant for only for flat roads. But they can take short turn because they're going 200, 250 kilometers, take very sharp turns. During that turn, vehicle should not topple. Right? So that's why this one. But commercial vehicle need little because the road bumps, the vehicle has to go in village road, all those things, which is not very flat. Right? That's why this is. Now, the main thing is when vehicle is going on the road, the job of what is job of the shock absorber to maintain the constant height between the tire which is touching road and the bottom of the vehicle. Correct, which is all ground clear. The same thing you have to maintain. But if the vehicle is moving over a road which has a speed bump, correct, speed breaker, we call it as a speed breaker. Let me show here. I'm showing a different color. There's a speed bump. Now, vehicle is moving with a forward as a 50 km speed. Correct. The bump has a height, for example, 20 centimeter or 15 centimeter height. Correct. It has a profile something like this. So, depending upon the angle, correct, this angle, correct, which is called actually literally speed breaker should be made like the flat road. It should have this angle, move up, then it should be a flat bottom top, and again should come down. This angle is fixed internationally. This width is fixed. This angle, how much this one? But nobody construct exactly like that. This one, correct? Otherwise, generally, we many times will see the things something like this, improperly made, something like this also. That means wheel will come and hit and it will be thrown up. Upward force is generated, correct? So normally the upward force is by 1g, correct? Because 1g gravitational force is acting, so the upward force also same. But when vehicle is moving, when tire is moving over the speed bump, depending upon the velocity and also this height, correct? So this height, the additional force is created. That additional force will be coming and acting on the sprung mass, inside which passenger is sitting, right? All the passenger drive plus driver are sitting. You want comfortable driving. That means the height should be constant. The sprung mass should not go from up and down because this is the height, correct? Ground clearance, GC. We say that it is, say, for example, 60 centimeter for a commercial car, correct? That should be maintained even when the vehicle tire goes over a speed bump. For that only shock absorber. See, additional energy coming because of the vertical acceleration when vehicle going over a bump, which should be absorbed by the shock absorber. That is job of that. So the additional force coming when the wheel goes over a speed breaker is called as shock. Correct? Shock. That energy should be absorbed. If it is shock absorber is not there, that will come to the sprung mass, which in turn will be subject to passengers. Passenger will be subject to upward acceleration, additional acceleration because of the force coming from the ground when wheel goes this one. That will make you body tissue to get tired. Correct? If road is, for example, this not paved road, village or something like that, undulations are there. When vehicle goes over this, correct, you will go up and down. The sprung mass will go up and down. That means acceleration is coming, additional force is acting, ground reaction force. That will make your body muscles to get tired. Some people can get, in fact, the brain will be affected. Brain tissues, neurons, for some people, when the road is too much this one, country a bumpy road, they get even headache, correct? They get vomiting, all those things. Continuous subjection, correct? Up to this kind of, in that case, you need a very good shock absorber. So the job of the shock absorber is to absorb the vertical energy coming from the road. When wheel is going over, uneven this, the vertical FG, additionally this one is absorbed by this, so that the the distance between the COG point, which is not ground clearance, is maintained with same 60 centimeter, irrespective whether the road is flat or wheel is moving over a bumpy road. If additional energy comes, that will be absorbed. That is done by the spring mass damper system. Okay. So similarly, another thing I have told is that we have a robot, as we already talked about. It has two joints. I say J1 and it has a J2. There are two joints, and this is connected to a frame. Right. So this is my joint 1, J1. This is joint 2. This is the bar. The frame is called L0 link. This is L1 link. Capital L1, this is capital L2 second link. Here I have end effector, and each joint is going to move with respect to L0. L1 can rotate, that is the joint angle, that is theta 1. Similarly, with respect to L1, L2 can rotate. If I activate the J2, as we know that we put two motors here, attach two motor M1 and M2. So that joint will move, my end effector moves. Correct? So I can move. So the end effector position is position of end effector. E position, which is nothing but xe, ye. It is a planar robot. Depends upon theta 1 and theta 2 and also L1 and L2. The location of the where the end effector will be there, that depends upon L1 and L2 of this small L1, sorry, length of this link and the second link, and also the theta 1, theta 2. Already we talked about forward kinematics, correct? Already I told you. Xe equal to, I told you, L1 into cos theta 1 plus L2 into cos theta 1 plus theta 2. Similarly, ye equal to L1 into sin theta 1 plus L2 into sin theta 1 plus theta 2. This is called a forward kinematics. This is called as a mathematical model. Using this, even without building this robo, you can find out if I change the theta 1, theta 2 for the given L1 or L2. Correct? This is a small L1, small L2. Right? So I can know where my end effector will go. I can write a program in Python, see something. I can run in Python. I can find out what will be the end effector position when I change the joint angle. Theta 1, theta 2, joint angle. So that's what this is done by controller, robot controller. So this equation is called mathematical model. Once mathematical model is there, I can know that whether my robot is working properly if I change the joint. For that, this is called a virtual modeling, which is called as virtual modeling using mathematical equation. That is called as mathematical modeling. All are same. Please, that's why I'm giving what are they different. Mathematical modeling. Mathematical modeling expressing the machine, correct, in terms of mathematical equation. And if I vary the system parameter like and this one theta 1, theta 2, L1, L2, I know where my end effector moves without making the robot. That is the advantage having mathematical modeling. I can run this program, I can vary this one, and I know whether really my end effector locates where this one. Once everything works, then I can make physical modeling. Correct? Virtual modeling and running this program as simulation. First, I write mathematical equation. Correct? I write mathematical equation. Already I forward kinematic equation. Already told you that equation will be written as a program, C or Python or some program. Correct? Or any other program, computer language or MATLAB, and then compile, run the program. Running the program is called simulation. I'm going to run the program in computer without building the actual robot. Correct? This is called a virtual modeling and virtual simulation. That means physically I not spend not even 1 penny to buy. Otherwise, you have to buy the some material for making links, joints, all the sensors, motors, and the controller. All these things to be made. And I try to run this one by writing program. If it doesn't work properly, what I have to do? I have to change the components. Correct? Components are there because I have change the parameter. I make a new joint, new link. All these things I have to make. In virtual modeling, without making an actual model, I can to develop this mechanical structure, correct? And I can give the joint angle theta 1 and run it through simulation and find out whether the end effector moves to correct location using forward kinematic model. Design, correct? This is called a mechatronic design. Because mechatronic design extensively uses computers. Mechatronic design uses computers extensively for modeling the machine. For example, mechanical system, you may use AutoCAD, correct? You make the 2D model, 3D model of the machine you can make and view in the screen, correct? You can rotate all those things. You can make with using on it, you can make 3D model. Please note that this is only a computer program you see on the screen, but you cannot touch it. There is no physical thing. They're called virtual model, AutoCAD. Once it is done, then you want to apply force, all those things. You want to analyze whether it can take load, all those things. Use a FE analysis, correct? Finite element analysis to find out how much load you can subject, how long you can run, applying forces, all this thing for same robot, right? Robot model. If it works, then you will do what you call dynamic modeling, dynamic analysis, correct? If you have worked on your machine design, correct, you will be knowing your company because, for example, Adams one software is there, right? Many software, the one of subject software is Adams, and FES is also available some software. AutoCAD already you know to make 3D model, all those things, and also you can make animation, 3D model and animate and see that whether the engine is working. You can see the piston moving, crankshaft moving, all those things, and you can find out, correct? So draw the 3D model using AutoCAD, animate if it is working, then you do FER. That AutoCAD drawing can be exported to FEA software, and you can do the static loading capacity, all this thing you can see, and the component size, how much load it can withstand. If it needed, you can change the dimension of the component, material, you can change all these things. And if it is that is okay, then you will find out dynamic analysis, how much additional force is created, whether the machine can withstand the dynamic forces apart from static forces. In machine, there are two type of force. One is called static force, other one is called dynamic force, right? In the FE analysis, you apply a constant load, which is not varying with respect to time, and see how much load it can take. You apply 1 Newton for 2 Newton for 5 Newton on a mechanical rod. For example, you have a rod, correct? As a cylindrical solid rod, one end is correct. You vary 0 to 10 Newton force, and you see whether this element, it has 10 centimeter length, it has 1 centimeter dia, and made of, for example, aluminum. Correct. AL is the material made, the cylindrical solid rod. Right. So you are applying a force. Correct. You can model this using AutoCAD. Correct. Then this model can be exported to FEA software. In FEA software, one side is arrested, so movement, what you call boundary condition. Other side you apply for 0 to 10 Newton. As you apply, you can see how much, whether there's a change in dimension. Correct. Stress and strain. Correct. Strain is nothing, change in dimension. So if you have to pay a compressive force, the dimension per 10, it can become 9.9 or 9.8. Correct, or less, depending upon what is the material made, how much force it can withstand, depending on type of aluminum. Okay, and you can use iron, or you can use stainless steel, SS, or different material you can try. All this thing, what you do, FA analysis, the material, you go to FA software, anybody use, you know that you can change the material just like that. You got the AutoCAD drawing, 3D model, and given to the FES software, and you have to say the boundary condition, how much load you have to apply, what material. You can, there is a selection is available, correct? You can say aluminum, plastic, the rod can be made of plastic, any material, solid material. Only thing it is made of solid material. Then you start applying forces. If dimensions, what force it is bending or it is shearing, correct? Anything, correct? The length changes, all this thing you can plot as a curve. They are called static. You are applying static force. You apply 1 Newton force, you see any dimension change. 10 centimeter reduce this one. You apply 2, 3, 4. When at 10 centimeter, you will see that it start crumbling, crushing. Correct? The dimension reduces, the diameter increases, length reduces. So that is you can measure all those things. Correct? That is what done is. They are static. In fact, it is not static force. You are as a quasi-static force. They call it, this is called as a quasi-static force, because you are varying the applied force slowly, not very fast, correct? Slowly. The force is varied with respect to time. So 0 to, for example, 1 minute, that is 60 seconds. Slowly you are increasing load, correct? 0 to 10 Newton. So what happens to dimension? I say length. How much length is changing? From original length, how much is changing, correct? It will start reducing, correct? So this is called quasi-static. This one, all these things are done using FEA. But next, what you do? Dynamic analysis. Correct? Dynamic analysis, you apply a shortened force, which is short duration. You apply 0 to 10 Newton force, correct? With say 1 second duration. You are not slowing. This is called dynamic. Dynamic, suddenly varying thing. Force is varying. In that case, what happens to your material? Your length of the rod, what happens? Dimension changing. How much stress is acting on each part? Correct? It is a straight rod. But in case if it a curved rod, something, some places more stress will be there, some part less, some places will break. Correct? Correct? So you may have a component of varying size, something like this. Correct? So I said this is a solid, but not equal. The diameter is varying and it is a curved causes. You are applying force. Correct? In this case, stress will be more here compared to here because the area is less. correct? Stress. So area force area. If more area is there per given force, the stress will become lesser. So that means as you increase force, this area will be more strain. After even 5 Newton force, this may break, but this area will not. This one. So suppose your component like that, you do apply static force, slowly varying quasi, this one you can do. But if you apply sudden force, immediately it will break. Correct? Dynamic force. If you want to do analysis, you can use dynamic force. But what I want to say here is mainly, you are not build the system at all. Everything you are doing on computer. If you use computer for making the modeling the system, using AutoCAD 3D model to see how the machine will look, shape, right? And then you do animation and 3D animation, then you can see whether the machine is working, all this thing you can see. Then you can do static analysis, dynamic analysis. And if anything change, you can change the material, dimension, all those things by this one. After that, everything works, then you make the prototype, physical prototype, right? So that is what the whole thing about mechatronics. That is why the mathematical modeling is very important. Modeling the mechanical system, mathematical modeling of mechanical system. Correct. So what I want to do is, if I want to do a mathematical modeling, first thing is you have to model individual components. Correct. You can model individual components. The system, spring mass damper system, has 3 components: one mass element, one spring element, one damping element. So together we call as spring mass damper system. Similarly, this robot has 2 link, one link 1, link 2. There's a joint 1, joint 2. They're all connected. Each one has some mass. Correct. It is a link can be mass element. Sometimes there may be some springs also in robot for restoring spring something. Then you have end effector. All this thing can be modeled. So this is called as a mechanical system. Now, when I wanted to talk about mechanical system, there are as I told you, I have a machine. Right? Machine have mechanisms, or sometimes we call as subsystems. Right? The subsystem consists of what you call a kinematic chain. Correct? Kinematic chain means 2 components connected by a joint. Correct? The joint can be a 0 degree joint, 1 degree joint, 2 degree joint, 3 degree joint. I will talk about what it is later when we are going to talk about subsequent classes. Kinematic chain. The kinematic chain is made of 2 elements connected by 1 joint. Correct? Then if you disassemble them, I start disassembling my machine. If I do that, I have a machine. Machine consists of mechanism or subsystems. Right? So, for example, we take a car. Engine is a subsystem. Car or the whole is a machine. It has engine. It has gearbox. It has transmission system. And it's a steering system. I'm talking main system. Now, engine, if I see, it has pistons, single cylinder, even it is piston. It has a connecting rod. It has a crankshaft. Correct. It has a camshaft. Then engine block. Correct. I'm talking engine. Then you will have valves, individual springs, valve springs, all this like this, many components. Correct. So similarly, if I see a robot, correct. For example, I have 6D robot. It has link 1 connected to joint 1. This is my link 0. Sorry, it is connected to link 1. Then it is connected to link 2. Then it is connected to another link 3. Then I have my wrist mechanism. It is connected to end effector E. Right? So this is, then I have J1, J2, J3, and there are J4, J5, and J6. There are 3 joints, 3 links in wrist mechanism. Together, we have the machine. Robot is a machine, full machine, correct? In which I can say this part has considered kinematic chain. First 4 links connected with 3 joints is called as main robo or main kinematic chain. Correct? And you have another this is one subsystem. Correct? For robot, this is a subsystem. Then I have wrist mechanism inside it. There are 4 links and connected by 3 joints. and finally it is connected to end effector. So this is another subsystem. And finally, I have end effector. End effector has a finger mechanism, which has many joints. Okay. Now, my robot is a machine. It consists of main robot with 4 links and 3 joints. That is one subsystem. This mechanism is another subsystem. Robot, main robot. I say main robot. Together, whole robot. This is called actually in robotic, first 4 links with first joint is called as robot. Additional thing is risk mechanism, which provide orientation tool. Then I have main robot. Then I have the risk mechanism. Then I have gripper. Gripper also has finger-like structure in small components. So these are called subsystems. And this main robot itself is called as kinematic chain. Correct? That is called a kinematic chain because link 0 is connected to link 1 through joint 1. Link 1 is connected to link 2 through joint 2, and link 2 is connected to link 3 through joint 3. So it is like a chain, one after another connected serially. That's why it is called kinematic chain. So the kinematic chain, if I remove, what happens? It has, in robotics, 2 links connected by joint is called, this is called the L1 link. I say this is L2. I call this is J2. This is called a kinematic pair. Correct? In robotics, 2 links connected by joint is called a kinematic pair. In this robot, how many kinematic pair are there? L0 connected to L1, 1 kinematic pair through J1. L1 connected to L2 through J2, the second kinematic pair. I call the KP1, KP2, and L2 connected to L3 to J3, KP3. Correct? KP3. So 3 kinematics are there. They are connected serially, which forms the kinematic chain, which I call the base of the main robot, which in turn is connected to this mechanism. Within that, there are 3 joints connecting 4 small links. So again, I get this one. There are 4 parts connected by a 3 joint. Then my finger like that. So that means a machine has the mechanisms or subsystems. The subsystem final disassembled in robot, for example, kinematic chain. In case of car, piston, rings like that. Gearbox, you can collect individual points, connecting rods, some small parts. Transmission also you can make it. So finally, if you disassemble the whole thing, you will get links and joints. Final elements in robot is links and joint. That is called fundamental building blocks of this system. Okay. So I just want to close this 2 more slides today. Any machine, if I disassemble, finally you get 3 basic elements, no doubt. The base element, which can be a spring, or it can be a solid component, or it can be this one, correct? So the element, if you see, that can classify spring element, mass element, damping element. Spring element, if you apply force, it will bend. So there's a elasticity. So that's why the spring element is called an elastic element. Sometimes spring element or elastic element. It can be used for storing potential energy, no doubt. The next one is called mass element, which is also called inertial element, and it can store dynamic energy. Correct? It can store dynamic energy or kinetic energy. Correct name is called kinetic energy. This is called as static energy or potential energy. Static or potential energy. This is called as kinetic energy. Mass element can store kinetic energy. Third one is called damping element, which is also called frictional element, which it cannot store energy. It can dissipate energy. Correct? Any mechanics is finally disassembled individually. Final components. If you take further, each component can be classified one of this. If you apply a force, if the component bends, it is called a spring element. If it doesn't deform, correct? But please note that there is no component which will not deform. Up to some load it can withstand. But theoretical mass element, even if you apply infinite amount of force, it should not bend. Correct? The shape, it should not deform. Correct? It has infinite rigidity. Theoretical, but practical one depending on material. Correct? If it is a plastic material, depending on the even apply, say 1 Newton force, it may shape can bend, or it can get compressed, or if you pull it, it can get expanded, after some force, up to some this one, the shape will be there. Beyond that force, it starts this one. If you know that stress strain curve, correct? Stress versus strain. You draw the curve. So this one. So being if it is a pure mass element, whatever stress applied, shape should not change. Correct? Even under heavy strain. But practical is not there. Third one is damping element. Damping element nothing but friction. Correct? If two solid or two surfaces are touching with a moving order, it provides an opposing force. Correct? The damping force or friction forces oppose a relative motion between two components. That is called as frictional element, damping element, which absorbs the energy what is supplied. Right? So another thing, this is basic elements. Next thing is what I want to say is the typical device. If a device can be passive element or passive system or passive elements. If I take two components, one component is a mass element, other one is also mass element. If I connect by a joint, again it forms a mass element only, correct? So the joint, if it's made of rigid material, the entire system, subsystem also still mass element only. Instead of that, if I take a mass connected by spring, then you have spring and mass damper system, correct? So again, the spring element, mass element, and damping element cannot produce power. These are called as passive elements. They are called as passive elements. They cannot produce force. Okay, but they can store for energy or dissipate energy. They cannot produce energy. Okay, if any subsystem or a machine made of this kind of passive element, it is called passive system. Instead of that, sometimes you have a system which can generate force and torque. For example, engine produces torque. A solenoid produces a force. Correct? A electric motor produces a torque. Those things are called as active elements. If the machine or subsystem cannot produce force or energy, it is called a passive system. Then type of motion, active element can produce two types of forces. One is called translation or straight line or linear motion. The second one is rotational, circular motion, angular motion. I stop here. You need to go for next class. Tomorrow we will continue. Okay. Please give your attendance.
Yes, sir.
Message, chat message.
Okay, sir. Okay. Sir, already given you. Thank you, sir.
Okay. Thank you. See you tomorrow.
Okay,
Thank you, sir.
Thank you, sir.
Yeah.
Okay, thank you, sir.
Okay.
Hello.
Yeah. Yes, please.
Sir, Vikas here.
Yeah. Yes, Vikas.
Basically, there was a request, sir,
Yeah.
regarding this subject. Basically, this mechanical systems. We all being sir industry students, mechanical systems we are very much aware, and we are into it day by day, daily. So these systems are very familiar to us.
Okay.
So maybe we can accelerate this mechanical systems topic,
Okay.
and we will maybe spend more time on mechatronic systems. So
We can do that, but anyhow, but yeah, we will do that. We will accelerate this because this will go for another 1 or 2 classes. That's it. Mechanical modeling. What we are going to, what is spring element? What is the, see, you not to write how to develop mathematical modeling, right? Basic things, what we are talking. And we are going to talk about what a damper, how to build from the basic element, how to build the mechanical system, right? And how to modeling the mechanical system using simple components. What is the mathematical modeling? What is a transfer function? All this thing you have to understand if you want to understand control system further.
yes, sir. Okay, sir.
No, just a thought, sir. Like I think, like means not all the people from in our batches, like from the mechanical. So I think the pace is good, sir. In my opinion, like
No. This course I'm teaching for last 20 years. This I am teaching for 20 years. My class students have electrical students from aerospace department, ocean engineering. Now I see some civil engineering students also because they are using robots, all those things for construction. Correct? They all wanted to understand mechatronics. This is a highly refined syllabus for last 20 years. which, because if you do this one course, whether a mechanical engineer, electrical or control system engineer, any other field, you will understand the entire thing. What is sensor, what is an actuator, what is mechanical modeling, how to model, develop model, what is an embedded controller, how to write program. All this you'll understand by attending 42 hours.
Agree, sir. Agree. Yeah, it's just in my opinion, because considering the people from a different domain, I think
Yeah,
the
no,
case
no.
is.
I definitely I will not, because this is refined. This is the best way of teaching, covering the entire this one. Knowing mechanical, knowing sensors, knowing about actuators. What is an actuator? What is electric motor? How it works? How the servo motor works? What hydraulic motor works? How to control hydraulic motor? How to model a hydraulic motor control? Everything we are going to see.
Agree, sir. Agree.
Yeah. Thank you.
Sure.
Anyhow,
Yeah, thank
his
you.
point also valid, but I am going to teach all the point. Don't worry. I'm not going to
Sure.
skip.
Sure. Thank you, sir. Thank you.
Because this course is taken by different students. Because even regularly on IIT also, my class strength is 100 students sometimes attend. 100 students from mechanical students and 50 students, around 10 from aerospace, electrical students. They are not doing any mechatronics, but now they are going. See, electrical student will go and join as an automobile company or company, correct? So he'll be designing ECU, all those things. You need to understand what mechanical, all those things. You want to have the basic. I take all the points, but still I am going to systematically explain everything.
Sure, sir. Sure. Yeah.
Okay, sir.
Sure. Thank you, sir. Thank you.
No problem. Okay, Vikas, thank you. See you, Siramvaram.
Sure.
See you
Thank
tomorrow.
You, sir. See you.
Thank
Yeah.
you.
See you, sir.
Thank you, sir.
Yeah. Okay. I will close the meeting. Thank you very much.
Thank you.